Hello everyone. Let us now start with the digital modulation techniques. We will cover the M-ary phase shift keying and M-ary quadrature amplitude modulation. Before I come to the PSK and QAM part, so in the previous lectures, I have already explained what is pulse amplitude modulation, or we can also call it as the amplitude shift key. I have described in my previous lectures the baseband modulation, baseband version of the pulse amplitude modulation. Now I have also explained the difference between the baseband and the passband. If I take the case of a pulse PT, I am referring to my previous lectures again. I am using the PT as the notation for representing the pulse that is being used to transmit digital information in terms of ones and zeros. So if I'm using PT as the pulse to represent the digital bit stream, and if I'm not multiplying it with any carrier frequency, so that will lead to baseband modulation. But if I multiply it with a carrier frequency, F naught or omega naught, then the modulation becomes a passband modulation, because in that case the spectrum of the wave spectrum of the uh, pulse that we are trying to represent the digital bit stream will be shifted at a higher frequency centered at f naught on the positive side, and on the negative side the spectrum will be centered at minus f naught. So it will be a band pass spectrum and it will be a real signal. So in that case, my pulse amplitude modulation will become the passband pulse amplitude modulation. Now, for example, if XMT is the transmitted signal, so how I can represent? I am representing with the AM, which is the amplitude. This is the PT, which is the pulse being used to represent the digital bit stream, and cos omega naught t is the carrier frequency. This carrier frequency is used to translate the frequency spectrum, the baseband frequency spectrum, to a higher frequency f naught. And we also know that this expression can be expressed in terms of the using the Euler's formula like this, and AMPT, this becomes the low pass equivalent of this band pass signal. We've already seen these things in my previous lectures. Now, if I specifically to pulse amplitude modulation, it is a one-dimensional. The constellation diagram of the pulse amplitude modulation is a one-dimensional constellation, meaning by if I take the one dimension, one single axis, so this is my origin, this is my first point, which is minus b. So b is the distance between the origin and the first point, either on the negative side or on the positive side. So this point will be minus b, this point will be at a distance b, and the distance between this point and this point is 2b. So therefore, from the origin, the distance of this point is 3b. So I am considering 4 points, minus 3b, minus b. This is of course the origin, but the point is b and 3b. So 4 points are there: minus 3b, minus b, b and 3b. These points are being used to represent amplitudes. So from the origin, the amplitude value is minus b. From origin to this point, the amplitude value is proportional to minus 3b, and on this side, on the positive side, the amplitude value for this point is b and proportional to b, and at this point the amplitude value is proportional to 3b. All right, so 4 points in this constellation diagram are used to represent 4 signals to be transmitted. Okay, so what does that mean? So I'm using 4 PAM, so I can use to represent minus 3b if I send this amplitude onto the communication channel, so this amplitude will represent 0 0. If I send this amplitude will represent 0 1. This amplitude will represent 1 0, and this amplitude may represent 1 1. So the different amplitudes will represent the four combinations of the 2-bit data in one symbol period. So that will be 4 p.m. And if I use only 2 points, so that will be 2 p.m. Meaning by, if I want to send 1, I will have let's say B as the amplitude proportional to B, and if I want to send 0, amplitude proportional to minus B. So that will be 2 p.m. And in general, I can say that if I use more combination of the, if I want to send 3 bits in one symbol period, so I will need 4 different amplitude levels, right? So in that case, my pulse amplitude modulation will become 8 p.m. and in general I can say that it is M array PAM. So we can express these points as um, so M is my 4, the value of M is 4 here in this particular example. So I can express the amplitude A naught in terms of M also. It will be minus M plus 1 B. So minus M is 4, minus 3 plus 1 is minus 2, so minus 2B. So that means it is minus 3B. So it will be, because M is 4, minus 4 plus 1 is minus 3B. So that will be this point. So A naught, this amplitude corresponds to A naught. And in the same way, A1 will correspond to this point, A2 will correspond to this point, and A3 will correspond to this point, 3B. So that means, and I will also consider a unit energy signal, and let us say I call this signal as the as phi t. Phi t is my unit energy signal, right? I will come to that point a bit later, maybe on the next slide. So XMT is the modulated signal, modulated with a frequency f naught, right? So if I want to calculate the energy of this signal, so the energy of this signal is given by xm square t, right? So what is xm square t? Xm square t will be equal to am square t square t and cos square omega. So if I try to substitute the value of xmt here, what is xmt? Xmt is given by am pt cos omega naught t. And if I try to solve this integral now, that means integral going from 0 to capital T xm square t, and I will substitute this value here, and I will find out that the energy of the message energy of the modulated signal will come out to be am square by 2 integral going from 0 to capital T p square t dt. And the integral going from 0 to capital T p square t dt is actually the energy of the pulse. So energy of the message or the modulated signal is equal to half am square ep. And now I can define a unit energy signal phi t. This is a unit energy signal along this dimension. So it is a unit energy signal. And what I want to do actually is, by defining this unit energy signal or the basis, what I want to do is that I want to express all the other points in terms of this unit energy signal. All these points actually represent the signals. So I want to represent 4 signals in the case of 4 p.m. in terms of this unit energy signal. So I define a unit energy signal, that means the energy of the signal is unity, and this signal is defined as under root 2 by EP. This is for the scaling factor, so that the energy comes out to be 1 pt cos omega naught t. And I want to how I can define now my xmt I can define in terms of phi t like this. Xmt will be equal to am under root of ep by 2 phi t. So what is my phi t? If I substitute phi t here, it is under root 2 by ep, right? So pt cos omega naught t, and if you solve it, you will find that xmt will come out to be this only. So what I have done is that I have defined a unit energy signal phi t, and I am trying to express all the signals in the 4 p.m. or in general for MRE PAM in terms of the phi t signal, right? So I'm using only one basis function because it is a one-dimensional modulation technique, and this is my phi t, and I will be able to express all the other signals in terms of this phi t. A point is taken representing unit length or energy, so that is that point from the origin, and all the points will be scaled version of unit energy point, right? Now, so this is all about the pulse amplitude modulation, which is a single dimension modulation technique. That means only amplitudes will be used to represent the uh, to represent the to represent the different combinations of the bits that we need to transmit in one simple period. So let us now come to phase shift keying. In the PAM or ASK, we were using amplitude of the carrier signal to represent the digital waveform, whatever we want to transmit. But here in PSK, the amplitude will remain constant, but we will use the phase of the carrier signal to represent different combinations of bits to be transmitted in one simple period. So if we define this signal pt cos 2 pi f naught t, no amplitude, but no amplitude put, we will introduce phase term instead rather than amplitude here. So what is this phase term? So in the case of phase shift keying, this is my modulated signal, and it is represented as pt cos 2 pi f naught t. This is my carrier frequency, and I want to add a phase term here, which is 2 pi by m multiplied with the small m. Capital M represents the number of signals in the constellation diagram. Small m represents the index of uh, each of the signal in the constellation diagram. Meaning by, let us say, if it is, let's say, in general it is M RE PSK, but let's say if it's a 4 PSK or QPSK to be more precise, in that case, four signals will be there. Four signals corresponding to four different phase terms will be there. Phase shift values will be there. So that means one signal will be used to represent 0 0. The other will be used to represent 0 1, then 1 0, and then 1 1. So four signals with different phase shifts, 90-degree to be precise, will be used to represent two bits of combinations in for each symbol period. And small m is the particular index for each signal. For example, m equal to 0, m equal to 1, 2, 3. These will be the signals present in the constellation diagram, right? Because the whole phase is 2 pi, so the whole phase will be divided by capital M. So the capital M is the number of constellation diagrams, number of points in the constellation diagram. So that means there will be capital M signals with different phases. So the whole phase of 2 pi will be divided with capital M, right? And we can traverse through each and every signal point through this small m, which is used as an index. Now I can also express this xmt in the using the Euler's formula, like pt e to the power j 2 pi f naught t plus 2 pi by capital M into small m, right? So this small t will be, that means the time, the time variable goes from 0 to capital T within one simple period. That simple period will be used to represent one combination of bits, one symbol, right? So that will form the modulated signal. And this 2 pi by m dot m into m will be a phase term, and this phase term will be used to represent different combinations of bits. For example, in the case of QPSK, that means four signals are to be there, four phase shift keying is there. then one signal will be with zero phase, corresponding to small m equal to 0, then small m equal to 1. So capital M in that case will be 4, because what is capital M? Capital M is the number of points in the constellation diagram. So how many, for a QPSK type of digital modulation technique, how many points are there? 4 points are there. So that means each signal will be differing from each other in with a phase difference of pi by 2, right? And to represent the phase, we need to represent, I mean, what I want to say is that the phase is to be represented in two dimensions, whereas in the case of amplitude modulation or pulse amplitude modulation, we used only one dimension to represent the amplitudes, whereas in this case where the phase shift keying is there, phase is two dimensions are used to represent the phase. So we will consider two basis signals or two unit energy signals, phi 1 and phi 2 t, and we will express all the points in terms of the phi 1 and phi 2 t signal. That means now what is my xmt? Xmt will be given by cos 2 pi m. If I expand this e to the power j 2 pi f naught t, and I will find out is that using uh, uh, if I use the term cos 2 pi f naught t, this term, okay, cos 2 pi f naught t plus 2 pi by m, 2 pi by capital M into m. So I can use the formula cos a plus b will be I mean cos a plus b trigonometric formula, and I can express this expression in terms of this. So this will be cos 2 pi small m divided by capital M pt cos of 2 pi f naught t plus sine 2 pi small m divided by capital M pt sine of 2 pi f naught t, and of course this is within one simple period. Now, if I try to find out the energy of this signal, I can find out using taking the integral, taking the square of xmt and integrating it from 0 to capital T. So I can find out the energy. And if you use the simple trigonometric relations, you will find out that the energy of the modulated signal is given by EP by 2, where EP is the energy of the pulse. So energy is, no phase term is coming. You see, energy of the modulated signal is just EP by 2. That means energy of each signal in phase shifting will be same. Therefore, PSK is a constant energy modulation technique. Each signal will have the same energy, right? And if if I try to plot the constellation diagram of a phase shift keying technique, how do you plot the constellation diagram? The constellation diagram of the amplitude shift keying was plotted by taking a single dimension. Let me come to that. By taking a single dimension, right, and expressing each point with this unit energy signal. Expressing each point with this unit energy signal means I can I can get the signals from these points using this basis function or unit energy signal. But since I'm using phase shift keying now, so how to represent the constellation diagram? Along the x-axis will be phi 1t, along the y-axis will be phi 2t, which is the second basis function. Two basis functions will be used to represent the x-axis and y-axis. Those will be the unit energy signals, and all the points in, I'm taking the example here of 16 PSK, so that means 16 points will be there. Why these points are on the circumference of this circle? Because it is a constant energy modulation technique. All the points will have the same energy. What is energy? Basically it is the distance, it is the square of the, it is proportional to the square of the distance from the origin to the point. So since it is a constant energy modulation technique, every point will find its locus on the circumference of the circle, right? And that will represent the same energy modulation technique. So if we want to include more points in the constellation diagram, then we need to take a bigger circle so that the distance between the points remain the same. Or if we keep the same size of the circle, same radius of the circle, then in that case If I try to take more points, then the neighborhood points will come closer to each other. Taking the more points, what do you mean by that? In case of 16 PSK, what is happening? So four combinations of bits, meaning by 0000 up to four ones, 16 combinations will be there. So these 16 signals are there, 16 signal points are there in the constellation diagram. So these 16 signals will be used to represent each combination of the digital bit stream that is to be transmitted to the channel within one simple period. But if you want to increase the number of bits to be represented with every signal, for example, if I want to make here 32 PSK, in that case there will be 32 points. And if I want to keep the distance between the 2 points the same, then I will have to increase the size of the circle. Increasing the size of the circle is equivalent to increasing the energy of the each point, and that will lead to more power consumption or battery power consumption, right? So, and if we do not keep the size of this circle, if we do not increase the size of the circle, so if and we want to increase the points, what will happen? The points will come closer to each other. Closer the points are, the there can be error in the decision making, that what was transmitted when you are trying to detect the signal at the receiver. So when the points are closer to each other, you can make a wrong decision. You have to make a trade-off. You have to make the points as close as the requirement of the system, so that the probability of error is also minimized, and at the same time the energy of the at the same time the energy should not go to higher side. Okay, so that's why the points will come close if we do not increase size of the circle, which leads to more probability of error. That is very obvious from the discussion that I have just tried to explain you. Now the two basis functions can be represented. Suppose the two basis functions of unit energy are phi1 and phi2t. I can express the, if I take the two basis functions as under root 2 by EP pt cos 2 pi f naught t, and the other phi other basis function is actually in quadrature with the previous one. That means phi 2t is in quadrature with phi 1t. There is a phase difference of 90 degrees. So I define phi 2t as under root 2 by EP pt sine 2 pi f naught t. These are what? These are unit energy signals, and these signals are orthogonal to each other. Meaning by the integral from integral phi 1t phi 2t dt will be equal to 0. So that is the orthogonality relationship when the two signals are orthogonal to each other. Now for complex signals, conjugate, if the two signals are complex, then conjugate of one of the signals need to be taken. That means phi 1t, phi 2t conjugate t dt. So that is the form, that is basically the formula to prove that the two signals are orthogonal to each other. Since we are taking real signals, so in that case, phi 1t, phi 2t we can put straight away rather than the conjugate of that, of one of the signals. But the point is that they have to be orthogonal to each other. There is a phase difference of pi by 2. So xmt, now the transmitted signal or the modulated signal can be expressed in terms of these two basis signals, phi 1t and phi 2t, like xmt am phi 1t and bm phi 2t. And where am is given by cos 2 pi small m by capital M under root of EP by 2, and bm is given by sine 2 pi m by capital M under root of EP by 2. Right. Now if I try to what is am and bm? These are the coordinates of the points in the constellation diagram. So AM comma BM are, for example, let's take the case of 8 PSK, where 8 points are to be there. This is first, second, third, fourth, and 8 points are there. Each point is representing a signal, right? So if I try to find out the coordinates of this point, how can I find out the coordinates of this point? This will be if you try to find out the am using if you try to find for different values of small m, if you tried and you for say 8 psk, if you take the capital M value to be 8 and you try to put small values of you try to put values of small m ranging from 0 to 7, then you can find out the coordinates of this point. The first coordinate is under root p by 2 comma 0. So this point will be under 1 over 2 under root p comma 1 over 2 under root p and so on. So you can find out the coordinates of all the points. So that means what are these AM and BM representing? AM and BM are representing two coordinates of the point of each point on the of the 8 PSK. And it is also important to mention here again that the points will lie on the circle. The locus of the points will be a circle, right? Because this is a constant energy modulation technique. And in the case of QPSK or 4PSK, 4 points will be there. Each point is representing a signal to be transmitted to further represent the combination of the bits that we need to send through the channel. So XMT can be represented as AM comma BM is a point in the plane represented by two axis defined by phi 1t and phi 2t. So the first, this x-axis is defined by phi 1t and y-axis is defined by phi 2t, right? So if I now try to find out, let's prove the energy of the signal is square of the, that's important because uh, this is origin. So these are the points on the circle. So we want to prove that the energy of the signal is actually the square of the distance of points from the origin. So how can we prove that? XMT is represented as AM phi 1t plus BM phi 2t. So XM vector, if XM is to be represented as a vector, XM vector is AM comma BM. So these are the coordinates of the points. And if I try to find out the energy of this signal, the modulated signal, it will be given by xm square t dt. And if I try to now, if I substitute the value of xmt with this am plus bm, I will get this am square phi 1 square t plus bm square phi square t phi 2 square t 2 am bm phi 1 t phi 2 t and dt. Because we also know that the integral phi 1 t phi 2 t, because these two signals are orthogonal to each other, this will, the third term will lead to 0, right? And if I extract am square out from here and bm square out from the second part, and I know that these are unit energy signals, phi 1 square t will be integral from minus infinity to infinity will lead to 1, and in the same way phi 2 square t dt integral from minus infinity to infinity will also lead to 1. So what is left is am square plus bm square, right? As phi 1t and phi 2t are orthogonal to each other. So energy is given by am square plus bm square, which is the square of the magnitude of vector xm. If this is the vector, these are excuse me, these are the points of the, these are the coordinates of the point, and if we try to find out the distance of this point from the origin, so that will be equal to am square plus bm square. So it proves that the energy of the signal is actually, energy of each point, energy of the signal is actually proportional to the square of the distance, square distance of xm from the origin. And what is the minimum distance between the points? So these are the points. So how can we find out the minimum distance or the distance between these 2 points? This is my first point, this is my second point. So I have to find out the distance. The square of the distance is xm minus xn, right? And distance between the points. Now if you try to if you try to put the value here using this formula of xm, formula you can try to put, and if you will solve it, you will find that it will come out to be ep 1 minus cos 2 pi by capital M m minus n. Now if we take m equal to small m equal to n, in that case it will be what is the minimum distance? How will you find out the minimum of this term? The minimum distance between the 2 points will be when m is equal to n. In that case, d min will be equal to ep 1 minus cos 2 pi by capital M, And as we increase them, right, as we increase the number of points in the in the in the constellation diagram, cos 2 pi by capital M will increase. So overall term will go towards zero. Probability of error will increase. That means if you try to find out the, if you try to increase the number of points, the distance between the 2 points will go towards zero. So as the distance becomes minimum between the 2 points, the probability of error will increase. That point I earlier also described, right? But this can be proven like this by finding out the distance between the two, minimum distance between the 2 points, and then estimating what should be the probability of error in that case, right? So I finish my discussion on phase shifting at this point. In the next lecture I will cover the quadrature amplitude modulation and other digital modulation techniques. Thank you very much.